Modified conjugate gradient coefficients under strong Wolfe line search and its application. Optimization is a decision-making tool that involves finding maximum or minimum value of a function. There are two types of optimization, but for this study, we'll be focused on unconstrained problem where the general form can be expressed as minimum x in our n for function x. This can be solved by the iterative method, which is xk plus 1 equals xk plus alpha k dk. Function fx is minimized at each iteration till fxk plus 1 less than fx. So, the alpha k in iterative method is the step size. The step size can be solved by line search. There are two types of line search, but we focus on inexact line search. There are also several types of inexact line search, but we focus on using strong Wolfe. The dk represent the search direction. Different search direction will lead to different method in optimization. Steepest descent focused on negative gradient. Newton's involved with inverse Hessian matrix. Quasi-Newton, on the other hand, is an improvement of Newton where it involves approximation of Hessian matrix, while conjugate gradient involves with scalar beta k. Why do we choose CG method? It is improved and faster than steepest descent method. Other than that, it has simple and efficient formulation. Also, it has low memory storage, which makes it ideal for solving large-scale optimization. CG method can be expressed as dk equals negative gk plus beta k dk1. There are several classifications of CG method, which are classical, hybrid, scaled, parametric, three-term, and modified. This study used modified CG method. These are the example of CG method with different classifications. Nowadays, the modification on CG coefficients has become popular among researchers in solving unconstrained problems. So, what is purpose of the study modified CG coefficients under strong Wolfe line search? Numerical test is important to test the efficiency and robustness of any new CG method. Since mostly CG methods are good in numerical test, it can be defined which modified CG coefficients has the best performance based on NOI and CPU. The modified CG coefficients with poor performance that have an increased number of iterations, NOI, and CPU time has limited capability to be applied in real-world problems, but can modified CG coefficients be implemented for regression analysis of labor force participation rate in Malaysia? The objectives are to study modified CG coefficients under strong Wolfe line search in solving unconstrained problems. To determine the performance of modified CG coefficients based on the number of iteration, NOI, and CPU time. To compare relative errors of modified CG coefficients with least square method and Excel Trendline for regression analysis of labor force participation rate in Malaysia. Modified CG coefficients chosen, which are RMIL+, SM+, LAMR+, and RMAR+. All these coefficients are tested by using Matlab subroutine programming. 15 test function, selected from Qt library, using 4 initial points and different scale variables, n equals 2, 4, 10. Lastly, we'll compare relative errors based on real-life dataset, which is labor force participation rate in Malaysia. According to Young et al., 2022, inexact line search is also often preferred in practice due to their computational efficiency, robustness, and flexibility in handling optimization problems. Besides, as said by Yabe and Sakaiwa, 2005, CG method does not require any matrix. The CG method is a most known and effective method for large-scale problems since it requires little memory storage. Lastly, according to Hajar et al., 2017, the modified CG method refers to variations made from the original CG coefficient to improve its efficiency. This adjustment aims to enhance robustness and efficiency of function. These are the selected CG coefficients that we used. This is the methodology used in the study. Based on this performance profile, we can evaluate the left-hand side and right-hand side of the graph. For the left-hand side of the graph, the higher curves, the faster method, while for the right-hand side of graph is the percentage of test problems solved by each methods. There are 162 total of test problems. The numerical results shows that LAMR+ is able to solve 100% of all the 162 problems, while RMIL+, SM+, and RMER+ yield 88.27%, 98.155, and 99.38% by solving 143, 159, and 161 test problems respectively. Thus, CG coefficients are applied in regression analysis. Regression analysis is to study the relationship among independent and dependent variables. RMIL+ is the only method that failed to solve the linear regression model. Thus, only these 3 methods are eligible to be applied in regression analysis for finding the relative error. In the summation of relative error for all tested method table, LAMR+ is slightly more accurate compared to other 2 coefficients in terms of sum of error and average error. Thus, LAMR+ is the most efficient and robust coefficient where it is able to yield the least relative errors compared to SM+, RMIL+, and RMER+. As all modified CG coefficients are tested under strong Wolfe line search based on numerical results, LAMR+ is the efficient and robust method. Only RMIL+ is failed for implementing in regression analysis for dataset of labor force participation rate in Malaysia. LAMR+ shows that it has least sum of relative errors compared to other methods, and it appears to be the best methods for implementation in regression analysis. The modified CG coefficients, which is RMIL+, SM+, LAMR+, and RMER+ have proven their capability and reliability in this research. There are others real data set for regression analysis or implemented in other field of application for the failed methods such as RMIL+. Thank you.